You are floating now, suspended in the thin air above the most pristine wilderness your planet has ever known. Below you stretch Antarctica continent wrapped in silence so profound it seems to have weight. The white canvas beneath you extends to every horizon, unmarked by human footprints, unburdened by the noise of cities or the rush of traffic. Here, at the bottom of the world, time moves differently. It breathes in millennia and exhales in centuries. The ice sheet below you is not merely frozen water. It is a living archive, a crystalline library where each layer holds the memory of ancient storms, volcanic eruptions, and the patient rhythm of seasons that have come and gone for hundreds of thousands of years. You drift lower, and the vastness begins to reveal its subtle textures. What appeared uniform from great heights now shows you gentle undulations, like the slow breath of a sleeping giant. This white expanse covers an area larger than the United States and Mexico combined. If you could somehow lift all this ice and set it down elsewhere, it would bury the entire continental United States under a blanket 2 miles thick. But numbers cannot capture what you feel as you descend through the crystalline air. The sense that you are approaching something both ancient and alive, something that has been waiting patiently for you to discover its secrets. The silence here is not empty. It is full of potential, pregnant with stories that whisper just below the threshold of hearing. As you settle onto the surface, your feet touch ice that fell as snow when your ancestors were learning to make fire. Some of this frozen water has not seen sunlight for 500,000 years. It has been compressed, layer upon layer, until it became something more than ice. It became a keeper of memories. You notice how the surface beneath your feet is not uniformly white. There are subtle blues that shift and dance as clouds pass overhead, casting shadows that reveal the ice's true depth. These blues are not painted on, they are created by the ice itself. When snow accumulates and compresses over centuries, it pushes out the air bubbles that would normally scatter light in all directions. Without these bubbles, the ice can only absorb the longer wavelengths of light, the reds and yellows, while allowing the shorter blue wavelengths to travel deeper before bouncing back to your eyes. This is why the heart of a glacier glows with the color of deep sky, why crevasses reveal walls that seem lit from within by some gentle blue fire. You are seeing the physics of light and matter made beautiful. The way compressed time takes on color and becomes visible to human eyes. As you stand on this frozen surface, you begin to sense the tremendous weight beneath your feet. The ice here is not a thin coating over solid ground. It is a vast, thick blanket that in some places measures nearly 3 miles from surface to bedrock. That weight, accumulated grain by grain over hundreds of thousands of years, presses down with such force that it has actually pushed the land beneath it below sea level in many places. The continent itself has settled under the burden, like a comfortable chair gradually conforming to the shape of someone who has sat in it for a very long time. But this weight is not static. It flows. Ice, when it accumulates to such thickness, begins to behave less like the solid frozen water you know from winter puddles, and more like an extremely thick, slow-moving liquid. The pressure from above causes the bottom layers to become plastic, malleable. They begin to slide and creep and flow, carrying cargo of rock and dust and trapped air bubbles on journeys that may take thousands of years to complete. You close your eyes and try to feel this movement, this imperceptible flow that is happening beneath your feet right now. The ice you stand on may be traveling toward the sea at a pace so slow that it would take several human lifetimes to move the length of a football field. Yet it is moving, carrying you and everything around you on a journey that began when this snow first fell, perhaps before human civilization began. The wind here speaks in a different language than wind anywhere else on Earth. It carries no sense of flowers or forests, no sounds of birds or insects. Instead, it brings you the pure essence of cold itself, air that has traveled across hundreds of miles of ice, picking up nothing but the subtle mineral breath of ancient snow and the sharp clarity that comes from absolute purity when you breathe. This air, you are breathing something that has touched nothing but ice and sky for perhaps thousands of miles. The temperature around you is not just cold, is a kind of cold that reshapes reality itself. Here, in the depths of Antarctic winter, the air can become so cold that it approaches the limits of what water vapor can tolerate. When you exhale, your breath doesn't just form the small clouds you might see on a winter day at home. Instead, it creates tiny crystals that fall like microscopic snow, each one a perfect geometric sculpture formed by the marriage of your body's warmth and the profound cold of this place. This cold preserves everything. In other places on Earth, organic matter decays, metals rust, and time erodes the traces of the past. But here, the cold acts like nature's greatest preservation system. Things that fall onto this ice weather, they are meteorites from space, ancient pollen grains, or bubbles of air from prehistoric atmospheres, remain virtually unchanged, waiting in frozen suspension for someone like you to discover them. You kneel and place your hand against the surface. Through your glove, you can feel the hardness of ice that has been compressed for centuries, but also something else, a subtle vibration, almost too faint to detect. This is the continent breathing. The ice expands and contracts with temperature. Changes, it creaks and groans as internal stresses build and release. Deep below, it slides across rock faces, generating sounds too low for human ears to hear, but powerful enough to be detected by sensitive instruments thousands of miles away. As you stand and look around you again, the scope of what lies hidden beneath this white canvas begins to dawn on you. This is not simply a continent covered by ice. This is a world within a world. A secret realm where lakes of liquid water exist in perpetual darkness, where mountain ranges taller than the Himalayas sleep under frozen blankets, where rivers flow in chambers that have never known sunlight. The surface you stand on is merely the roof of this hidden world. Below you, separated by miles of compressed snow and ice, lie landscapes that would astonish you with their diversity and beauty. There are valleys that make the Grand Canyon seem modest, lakes that dwarf the Great Lakes of North America, and geological formations that tell stories of when this frozen continent was warm and green and alive with forests. You realize now that your journey is just beginning. This white canvas above which you floated, this pristine surface on which you now stand, is not a destination but a doorway. The real Antarctica, the continent of hidden wonders and ancient secrets, lies beneath your feet, waiting in the darkness below the ice. The wind shifts slightly, carrying with it a sound so faint you're not sure if you heard it or imagined it, a whisper that might be ice settling, or water moving in hidden channels far below, or simply the voice of this frozen world calling you deeper into its crystalline embrace. You stand now on what seems like the most solid surface on Earth, miles of compressed ice stretching in every direction. Yet beneath your feet, in chambers carved from darkness and pressure, water flows as freely as any river you have ever known. This is one of Antarctica's most beautiful secrets. Hidden beneath the frozen silence above, an entire network of liquid, Waterways moves through the continent like the circulation system of some vast, sleeping creature. These underground rivers are not like the streams and brooks that babble through forests and meadows above ground. They flow in perfect darkness, never touched by sunlight, never stirred by wind or weather. Some of these waterways are older than human civilization, carved slowly over millennia by the patient work of pressure and heat from the Earth's core below. The weight of the ice above creates such tremendous pressure that it actually lowers the freezing point of water, allowing it to remain liquid even in temperatures that would instantly freeze any surface stream. Imagine, if you will, a vast subway system built not by human hands, but by the physics of pressure and temperature. These tunnels and channels wind their way through the bedrock beneath the ice, connecting distant parts of the continent in ways that satellite images could never reveal. Water that begins its journey near the South Pole might eventually find its way to the Ross Sea, traveling through a network of passages that exists in complete secrecy, hidden from the world above. The source of this water is as remarkable as the rivers themselves. Some of it comes from the slow melting of ice at the very bottom of the ice sheet, where the pressure from miles of ice above and the gentle heat rising from the Earth's interior create conditions warm enough to melt even the most ancient frozen layers. Other water seeps down through tiny cracks and fissures in the ice, following pathways that might take decades or centuries to complete their downward journey into the hidden waterways below. But perhaps the most fascinating source is geothermal heat, from the Earth itself rising up through the bedrock to create pockets of warmth in the frozen world above. Antarctica sits above geological features that channel the planet's internal heat upward, creating underground hot springs and heated chambers, where ice meets rock and transforms back into its liquid form. These geothermal areas act like underground furnaces, generating not just water but entire ecosystems that exist in perpetual darkness. As you imagine these rivers flowing beneath you, picture water that is unlike any you have ever seen. This is not the clear mountain stream or the muddy river of a rainy day. This subglacial water often carries a heavy load of minerals dissolved from the bedrock it has touched during its long journey through stone and ice. It may be rich with iron, giving it a reddish tint, or loaded with other minerals that create colors ranging from deep amber to pale green. Some of this water has been isolated from the surface world for so long that it contains concentrations of minerals found nowhere else on Earth. The movement of these hidden rivers creates its own geography. Over thousands of years, flowing water carves channels in the bedrock, creating valleys and canyons that will never see daylight. These underwater landscapes are sculpted by the same forces that create the Grand Canyons and river valleys of the surface world, but they exist in a realm of perpetual night, known only to the water that carved them and the occasional scientific instrument brave enough to venture into these hidden depths. Some of these rivers are vast, wider than the Mississippi, deeper than any surface river on the continent above. Others are mere trickles, threading their way through narrow passages in the rock like liquid veins in a vast body. But all of them are connected, part of a circulation system that moves water, minerals, and energy through the continent in patterns that scientists are only beginning to understand. The temperature of these waters varies dramatically from place to place. Near geothermal vents, the water might be warm enough for a comfortable bath. In other areas, it hovers just above freezing, kept liquid only by the tremendous pressure of the ice above. This variation in temperature creates currents and flows, as warmer water rises and cooler water sinks. generating circulation, patterns that help distribute heat and minerals throughout the hidden network. These underground rivers do not flow in isolation. They connect to hidden lakes, vast bodies of water trapped beneath the ice in chambers that have remained sealed for millions of years. When a river flows into one of these subglacial lakes, it brings with it minerals, nutrients, and sometimes even microscopic life from distant parts of the continent. When water flows out of a lake to continue its underground journey, it carries with it the chemical signature of that hidden body of water, creating a complex web of connections that links the entire continent in ways invisible from above. The speed of these rivers varies as dramatically as their temperature and chemistry. Some sections flow quickly, rushing through narrow channels with the urgency of a mountain stream. Others move with the patience of geological time, taking years to travel distances that a surface river might cover in days. The fastest of these hidden waterways can move several feet per day swift by underground standards, though still slow enough that a leaf dropped into the current would take months to travel from one end of the continent to another. What makes these rivers even more remarkable is their role as messengers. The water flowing beneath your feet right now might carry chemical signals from volcanic activity happening hundreds of miles away. It might transport minerals that tell the story of ancient rock formations deep beneath the ice. Some of this water eventually finds its way to the ocean, where it influences the chemistry and temperature of the seas around Antarctica, affecting ocean currents that reach around the globe. Scientists have discovered that these hidden waterways are not static. They change their course over time, responding to shifts in the ice above, changes in pressure, and variations in the geothermal heat rising from below. Like rivers on the surface that occasionally change their channels after floods, these subglacial streams can carve new pathways or abandon old ones, creating an ever-evolving network that pulses with its own rhythm beneath the seemingly unchanging ice above. The water in these rivers has its own ecosystem, its own community of life adapted to conditions that would be impossible for most living things. In the complete darkness, in water that may not have seen sunlight for millions of years, microscopic organisms have found ways to thrive. They create their own food from the minerals in the water, generate their own energy from chemical reactions, and build communities that exist entirely independent of the step-out world above. As you stand on the ice and contemplate these hidden waterways flowing beneath you, you begin to understand that Antarctica is not the barren, lifeless wasteland it might appear to be from the surface. Instead, it is a continent alive with movement, circulation, and connection. The ice above may seem solid and permanent, but it rests on a foundation of flowing water, moving minerals, and circulating energy that connects every part of this frozen continent to every other part. The sound of this hidden water system is too deep and too distant for your ears to detect. But if you could somehow hear it, you might catch the gentle murmur of currents flowing through stone channels, the soft splash of a hidden waterfall, or the quiet lapping of waves against the shores of a lake that has never known daylight. And as you imagine these sounds, this hidden symphony of flowing water in the darkness below, begin to wonder what other secrets might be locked away in chambers even deeper than these rivers, in the solid rock foundations that support both the flowing water and the miles of ice above, beneath the flowing rivers you have just discovered. Deeper still, in the hidden architecture of this frozen continent, sleep the most magnificent mountain ranges on Earth. You cannot see them from where you stand on the ice above, yet they rise from the bedrock in chains more dramatic than the Himalayas, more extensive than the Rockies, more ancient than the Alps. These are the sleeping giants of Antarctica peaks that have not felt sunlight on their slopes for millions of years, summits that touch not sky, but a ceiling of ice so thick it might as well be stone. Imagine mountains so tall that if you could somehow remove all the ice above them, their peaks would pierce the clouds and scrape the edge of space itself. The highest of these buried giants reaches nearly 2 miles above the hidden landscape around it. Yet its summit still lies almost a mile beneath the surface of the ice sheet. It is a mountain within a mountain, a peak wrapped in a blanket, so thick that it has become part of a different world entirely, the white world above, where you now stand. These sleeping ranges were not always buried. Once, in Earth's distant past, they stood proud and exposed, their granite faces catching the light of ancient suns, their slopes covered with forests and streams. But as the climate cooled and ice began to accumulate, these mountains became the foundation for the great ice sheet that now covers the continent. Layer by layer, year by year, the ice grew thicker until it swallowed first the foothills, then the middle slopes, and finally even the highest peaks. The ice did not simply cover these mountains, embraced them, flowed around them, filled their valleys, and smoothed their contours. Over millions of years, the tremendous weight of accumulated ice pressed down on these peaks with such force that it actually changed their shape. The ice ground against the rock, polishing surfaces that no human eye has ever seen, carving valleys between peaks that exist now only in the realm of imagination and scientific instruments. You can think of these buried mountains as sleeping giants because they exist in a state of suspended animation. On mountains exposed to air and weather, rock faces are constantly changing, cracking with frost, eroding in rain, wearing away grain by grain in the wind. But under the ice, these peaks exist in a world without weather, without seasons, without the constant wear and tear that shapes the mountains, you know. They sleep in geological time, preserved in the darkness like ancient artifacts in a museum vault. The rock that forms these hidden peaks tells stories that stretch back to the very formation of the earth. Some of these mountains are made of granite that crystallized from molten rock deep in the Earth's crust billions of years ago, when the planet was young and the surface was still cooling from its violent birth. Other peaks are built from sedimentary rocks that formed on the floors of ancient oceans, compressed and lifted by forces so powerful they could raise the seafloor higher than the clouds. Between these buried peaks lie valleys that would take your breath away if you could see them. Some are narrow gorges that slice through the rock like knife cuts, carved by rivers that flowed here when Antarctica was warm. Others are broad valleys that could contain entire cities, their floors now filled with ice that has flowed down from the peaks, above like the slowest glacier imaginable. The ice that surrounds these sleeping mountains is not uniform. Near the peaks, where the bedrock rises close to the surface, the ice flows differently than it does over the deep valleys. It speeds up as it moves around the buried summits, creates eddies and currents in its slow-motion flow, and sometimes forms features on the surface far above that hint at the dramatic topography hidden below. These mountains influence the hidden rivers you learned about in ways both subtle and profound. Water flowing through the underground network must navigate around these buried peaks, following valleys and channels carved in the bedrock. Some rivers disappear into underground caverns in the mountains, emerging on the other side, changed by their journey through the heart of stone. Others split around mountain barriers, creating multiple channels that may not reunite for hundreds of miles. The geothermal heat that warms some of the underground rivers often originates in these buried mountains. The rock faces under tremendous pressure from the ice above sometimes generate heat through friction. Ancient radioactive elements trapped in the granite cores of these peaks decay slowly over millions of years, releasing energy that warms the ice above and creates pockets of liquid water in places where, by all logic, everything should be frozen solid. If you could somehow descend through the ice to walk among these sleeping giants, you would find landscapes of breathtaking beauty and strangeness. The ice has filled the spaces between peaks like a slow-moving liquid, creating formations that are part glacier, part sculpture. Where the ice meets the rock, it has formed caves and caverns, some large enough to contain cathedrals, their walls glowing with the deep blue light that penetrates down through the ice above. The silence around these buried peaks is more complete than any silence you have ever experienced. No wind howls through their valleys, no streams babble down their slopes, no birds call from their heights. Yet they are not truly silent, they speak in the language of geology, the slow conversation of rock under pressure, ice under stress, and time measured in epochs rather than heartbeats. Some of these mountain ranges extend for hundreds of miles beneath the ice, their peaks and valleys creating an entirely hidden landscape that rivals any mountain system on the exposed continents. The Transantarctic Mountains, which you can see in some places where they rise above the ice sheet, are merely the visible portion of a much larger mountain system that extends far beneath the frozen surface, like the tip of an iceberg revealing only a fraction of its true size. The sleeping giants influence weather patterns far above their buried peaks. The shape of the bedrock affects how the ice flows, and the flow of ice affects the winds that blow across the surface. Storm systems moving across Antarctica respond to these hidden mountains in ways that meteorologists are only beginning to understand, creating weather patterns that seem to arise from the flat white surface but actually originate in the complex topography sleeping miles below. These buried peaks also serve as repositories of Earth's history in ways that exposed mountains cannot. Protected from erosion by their blanket of ice, they preserve rock formations and mineral deposits that have been worn away elsewhere on the planet. They hold crystals that formed when the Earth was young, fossils that tell stories of ancient climates, and geological formations that provide clues to how continents moved and collided over billions of years. As you stand on the ice above these sleeping giants, you might feel a subtle difference in the surface beneath your feet, slight change in the texture of the ice, a barely perceptible variation in the way the wind moves across the snow. These hints from far below are the only signs that you are standing above some of the most magnificent mountains on Earth. Peaks that dream in darkness and wait with the patience of stone for the ice to retreat and the sun to wake them once again. The thought of these sleeping giants beneath your feet fills you with wonder and a kind of geological vertigo, the realization that the solid surface you stand on is merely the roof of a hidden world as complex and beautiful as any landscape above ground. And as this wonder settles into your mind like snow settling on ice, you begin to sense that even these magnificent buried mountains are not the deepest secret hidden beneath the frozen surface, that there are chambers and spaces between the peaks where water gathers in bodies so vast and isolated they form their own quiet worlds, completely separate from the rivers and streams you discovered flowing in the darkness above. Deep beneath the sleeping giants you have just discovered, cradled in valleys that have never known starlight, lie bodies of water so pristine and isolated that they exist like liquid jewels in chambers of eternal darkness. These are Antarctica's hidden lakes, not the frozen ponds or ice-covered seas you might imagine. but vast expanses of liquid water that have remained unfrozen for millions of years, sealed away from the world above by barriers of ice thicker than mountains are tall. Imagine, if you can, a lake the size of Lake Ontario, its surface as smooth as polished obsidian, reflecting not sky or clouds but the gentle blue glow of ancient ice formations far above. The water in this hidden sanctuary has never felt the touch of wind, never been stirred by storms, never been disturbed by anything more dramatic than the occasional gentle current created by temperature differences in its depths. It is water, in its most peaceful state, liquid meditation held in a bowl of stone and ice. These subglacial lakes exist because of a delicate balance of forces that seems almost magical in its precision. The tremendous weight of ice above creates pressure so intense that it lowers the freezing point of water by several degrees. Meanwhile, heat rising from the Earth's core below, combined with the insulation provided by miles of ice, keeps the bottom of these chambers just warm enough to maintain liquid water. It is as if the planet itself has created these hidden sanctuaries, protecting them with barriers of cold above and warming them with gentle heat from below. The largest of these liquid dreams is Lake Vostok, a body of water so vast that if you could somehow remove all the ice above it and stand on its shores, you would not be able to see the other side even on the clearest day. This lake has been sealed beneath the ice for more than 15 million years, isolated from the surface world since before your earliest human ancestors walked upright, before the continents settled into their current positions, before the climate patterns you know today had even begun to form. The water in these lakes is unlike any water you have ever encountered. It has been filtered through miles of ice over millions of years, purified to a degree that makes distilled water seem cloudy by comparison. Yet it is not empty, it carries within it minerals dissolved from the bedrock below, creating a chemical composition that tells the story of the rocks it has touched and the geological processes it has witnessed. During its long isolation, some of these hidden waters are supersaturated with gases that have been dissolved under the tremendous pressure of the ice above. If this water were somehow brought to the surface, it would bubble and fizz like champagne as the dissolved gases escaped, creating a natural carbonation that has been building pressure for geological ages. The water contains nitrogen, oxygen, and other gases in concentrations found nowhere else on Earth, preserved under pressure, like messages in bottles that have been waiting millions of years to be opened. The temperature of these liquid sanctuaries varies in ways that create their own weather systems in miniature. Near the lake bottom, where geothermal heat seeps up through the bedrock, the water might be several degrees warmer than at the surface where it touches the ice ceiling above. This temperature difference creates gentle convection, currents warm, water rising, cooling as it approaches the ice above, then sinking back toward the depths in a circulation pattern so slow and steady it has continued unchanged for millennia. These circulation patterns create layers within the lakes, each with its own characteristics and chemistry. Like the layers of sediment that accumulate on lake floors over time, the water itself becomes stratified, with older water holding different mineral concentrations than newer water, creating invisible boundaries that have remained stable for thousands of years. If you could somehow see these layers, they might look like the bands in an agate stone, distinct zones of slightly different composition, stacked one upon another in the liquid darkness. The shores of these hidden lakes are unlike any coastline you could imagine. Instead of beaches or rocky cliffs, The water meets walls of ice that have been sculpted by millions of years of gentle lapping. The ice at the water's edge takes on fantastic shapes, smooth curves, where the liquid has worn away irregularities. Delicate formations where minerals in the water have crystallized against the ice walls, creating natural sculptures that exist in complete darkness, their beauty known only to the water that shaped them. In some places, these lake shores drop away into depths that would challenge the deepest parts of the oceans above. Lake Vostok, despite being trapped beneath miles of ice, reaches depths of more than half a mile, in some places a liquid canyon carved into the bedrock over geological time. Other hidden lakes are surprisingly shallow, spreading across wide basins like dark mirrors reflecting the ice formations above. The silence in these liquid chambers is more profound than the silence of the ice above or the stone around them. Water absorbs sound differently than air, creating an acoustic environment where even the smallest disturbance, a bubble of gas escaping from solution, a tiny fragment of ice falling from the ceiling above, becomes magnified and carried through the liquid medium in ways that would seem impossible in the dry world of the surface. Yet these lakes are not lifeless. In water that has been isolated from sunlight for millions of years, in temperatures that hover just above freezing, in pressures that would crush surface-dwelling organisms, life has found a way. Microscopic communities thrive in these liquid sanctuaries, organisms so adapted to their unique environment that they represent entirely new branches of the tree of life. These creatures create their own energy from the minerals in the water, build their own food from chemical reactions, and reproduce in ways that evolution has crafted specifically for existence in eternal darkness. Some of these lake-dwelling organisms might be descendants of ancient life forms that existed when Antarctica was still warm, trapped beneath the ice as the continent froze and evolving in isolation for millions of years. Others might be more recent arrivals, carried into the lakes by the underground rivers you discovered earlier. Immigrants from the network of waterways that connects these hidden sanctuaries to distant parts of the continent. The chemistry of these isolated waters creates conditions that exist nowhere else on Earth. Some lakes are rich in iron, giving their waters a reddish tint that would make them look like liquid rust if you could see them. Others contain high concentrations of sulfur compounds, creating an environment more like the hot springs of Yellowstone than the cold lakes of the surface world. Each lake has developed its own unique chemical signature over millions of years of isolation, like fingerprints written in dissolved minerals and trace elements. The ice that forms the ceiling of these liquid chambers is not ordinary ice. Under the tremendous pressure and in contact with the mineral-rich water below, it takes on properties that make it almost like a living interface between the solid world above and the liquid world below. This ice grows and melts in slow cycles, sometimes adding to the volume of the lakes below, sometimes taking water away, breathing like a vast, slow lung that inhales and exhales over geological time. Where the underground rivers connect to these hidden lakes, they create underwater deltas and estuaries, places where the flowing water from distant parts of the continent meets the still water of the lake sanctuaries. These underwater meeting places become zones of mixing, where the chemistry of the rivers blends with the ancient chemistry of the lakes, creating gradients of temperature, mineral content, and even life that exist in layers and zones throughout the water column. Some of these lakes are connected to each other by channels and passages that allow water to flow from one hidden sanctuary to another, creating a network of liquid chambers that communicate through underwater rivers and streams. A drop of water that begins its journey in one lake might travel through underground passages for hundreds of miles before emerging in another liquid sanctuary, carrying with it chemical messages and microscopic passengers from its place of origin. The age of the water in these lakes spans a range that challenges human comprehension. Some water near the surface, where the ice ceiling occasionally melts and refreezes, might be only thousands of years old. But water in the deepest parts of these lakes, water that has settled to the bottom and remained undisturbed, might have been liquid. Since before complex life existed on Earth, it is water that remembers climates from the planet's distant past. Water that has witnessed the rise and fall of species, the movement of continents, and the slow dance of geological time. As you contemplate these liquid sanctuaries hidden beneath miles of ice, you begin to understand that they represent more than just bodies of water. They are time capsules, preserving samples of ancient Earth in their dark depths. They are libraries written in liquid, their chemistry and biology holding clues to questions about life, climate, and planetary history that scientists are only beginning to learn how to read. The gentle currents that move through these dark waters carry more than just dissolved minerals and microscopic life. They carry the patient wisdom of deep time itself, the accumulated knowledge of millions of years spent in quiet contemplation beneath the ice. And as you imagine these currents flowing in their eternal darkness, you begin to wonder what stories the very ice above these lakes might tell, what memories might be preserved in the frozen layers that have accumulated grain by grain, year by year, creating an archive of Earth's climate that stretches back through ages beyond counting. Above the hidden lakes you have just explored, compressed into the ice that forms the ceiling of those liquid sanctuaries, lies the most complete library of Earth's climate history ever assembled. This is not a library built by human hands, with books and shelves and reading rooms, but a library written by time itself, page after page of frozen chronicles, stacked one upon another in layers so thin that thousands of them together measure only the height of a person. Each layer of ice began as a single year's snowfall, settling onto the surface during some distant winter, when your ancestors may not yet have learned to speak or build fires. As new snow fell in the years that followed, the older layers beneath were compressed, squeezed by the weight of accumulating time until they became part of the permanent record, pages in an autobiography that the Earth has been writing about itself for hundreds of thousands of years. You can imagine this library as a vast vertical book, with its oldest pages at the bottom and its newest pages at the top. To read this book, you would not turn pages from side to side, but would instead descend through layers, traveling backwards through time as you go deeper into the ice. Each page, each thin layer tells the story of a single year in Earth's long life, recording the temperature of ancient summers, the snowfall of forgotten winters, and the chemical composition of atmospheres that no living person has ever breathed. The writing in this frozen library is not made of ink on paper, but of isotopes and molecules, chemical signatures that tell their stories to scientists who have learned to read the language of ancient ice. When snow fell thousands of years ago, it carried within its crystal structure a record of the temperature of the clouds from which it formed. Warmer years left their signature in one type of oxygen isotope, cooler years in another, creating a thermometer made of frozen time that still functions today. But temperature is only the beginning of what this ancient library records. Trapped within the layers of compressed snow are bubbles of air, tiny capsules that preserve actual samples of the atmosphere from ages past. These air bubbles are like messages in bottles, holding within them the exact composition of the air that people might have breathed if people had existed when the snow first fell. Some of these bubbles contain air from times when the atmosphere held different amounts of carbon dioxide, different concentrations of methane, different balances of the gases that determine how warm or cold the planet becomes. The ice also preserves the dust that settled onto the snow in ancient years, creating a record of volcanic eruptions that darkened skies before recorded history began. When a massive volcano exploded somewhere in the world, it sent ash and particles into the atmosphere that eventually settled onto the Antarctic ice sheet, where they became part of the permanent record. Scientists reading these frozen pages can identify specific eruptions, determine their size and location, and understand how they affected global climate patterns. In some layers, the ice holds traces of cosmic dust, microscopic particles from space that drifted down through the atmosphere and settled onto the snow like glitter from distant stars. These cosmic visitors tell stories of the solar system's journey through space, recording times when Earth passed through the debris, trails of ancient comets, or encountered clouds of interstellar dust that had been traveling through the galaxy for millions of years. The most fascinating pages in this library are those that record dramatic changes in Earth's climate system. Some layers show evidence of years when the planet's temperature shifted suddenly, when ocean currents reorganized themselves, when ice ages began or ended. These transition periods are written in the ice like chapters of great drama stories of a planet adapting to new conditions, finding new balances, discovering new ways to regulate its temperature and weather patterns. You can think of reading this library as listening to Earth's breathing over hundreds of thousands of years. Some periods show the slow, steady breathing of a stable climate, with each layer representing a calm, predictable year, much like the one before it. Other sections reveal periods when the planet's breathing became rapid and irregular, when climate systems shifted quickly from one state to another, like a sleeping person entering a phase of restless dreams. The deepest, oldest pages of this library record times when Antarctica itself was a very different place. In the bottom layers, compressed by the weight of everything above them, lie records of years when this continent was warmer, when rain fell instead of snow, when plants grew in what is now frozen wasteland. These ancient pages tell stories of a green Antarctica, a place where forests grew and rivers flowed freely under open skies. Some layers preserve evidence of ancient seasons in remarkable detail. You can read the story of individual years, wet springs that brought heavy snowfall, dry summers that left their mark in the chemical composition of the ice, stormy autumns that deposited unusual amounts of sea salt carried inland by powerful winds. These seasonal stories, multiplied by thousands and laid one upon another, create patterns that reveal how Earth's climate systems have evolved and changed over timescales that dwarf human history. The library also contains records of events that happened far from Antarctica but affected the entire planet. Forest fires in distant continents left their chemical signatures in the ice. Changes in ocean circulation patterns altered the types of snow that fell. Even events in space, variations in the sun's energy output, changes in Earth's orbit around the sun left their marks in these frozen pages, creating a record of how cosmic forces shape planetary climate. Reading this ancient library requires patience and skill the scientists have spent decades developing. The stories written in isotopes and air bubbles must be decoded carefully, cross-referenced with other evidence, interpreted in the context of what is known about how climate systems work. But the effort reveals treasures of knowledge that exist nowhere else, direct evidence of how Earth's climate has behaved over timescales long enough to see the full range of natural variability, the complete cycles of warming and cooling, the rhythms that govern how the planet regulates its temperature. Some pages in this library are written more clearly than others. Years with dramatic events, major volcanic eruptions, sudden climate shifts, periods of extreme weather left bold signatures that are easy to read even in ice that is hundreds of thousands of years old. Other pages require more careful study. Their stories written in subtle variations that become clear only when compared with the pages above and below them. The act of reading this library is also an act of time travel. When scientists extract cores of ice from deep within the ice sheet, they are bringing to the surface actual pieces of ancient years' snow that fell when mammoths walked the earth, air that was breathed by the planet when continents were arranged differently than they are today. The ice in their hands contains water molecules that were once part of ancient clouds, that once evaporated from prehistoric oceans, that once fell as rain in forests that have long since turned to stone. As you contemplate this vast library of frozen time stretching beneath your feet, you begin to understand that you are standing not just on ice, but on history itself. The accumulated stories of hundreds of thousands of years, each one preserved with perfect fidelity in the crystalline archive below. The weight of all those years, all those seasons, all those ancient storms and calm periods, presses down through the ice layers like the weight of memory itself. And as you imagine the stories written in those countless layers, tales of warm periods and ice ages, of volcanic winters and peaceful summers, of a planet learning through deep time how to maintain the delicate balance that allows life to flourish, you begin to wonder what other forms of life might have learned to read these same stories, what microscopic communities might have discovered their own ways to interpret the chemical messages preserved in the ancient ice. Within the ancient library of ice you have just discovered, between the pages of frozen time and in spaces so small they exist beyond the reach of human vision, flourish cities more populous and complex than any metropolis ever built by human hands. These are the microbial cities of Antarctica's ice-vast communities of microscopic organisms that have learned not just to survive, but to thrive in conditions that would seem impossible for life. In temperatures far below freezing, in darkness so complete it has never been broken by a single ray of sunlight. In spaces so confined that millions of inhabitants live in an area smaller than the head of a pin. Imagine, if you can, a city where the buildings are made of ice crystals, where the streets are microscopic channels filled with briny water that never freezes, where the inhabitants glow with their own soft light and create their own food from nothing more than minerals and chemical reactions. This is not a city of science fiction, but a real community that exists right now, perhaps only inches from where you stand on the surface. Embedded in the ice like a living jewel in a crystal matrix, these invisible civilizations exist because life has discovered something remarkable about ice. It is not the sterile, lifeless substance it appears to be from the outside. When water freezes slowly, as it does in the deep layers of Antarctic ice, it forms crystals that are not perfect solid blocks, but complex structures riddled with tiny spaces. Microscopic pockets of liquid water that remain unfrozen even in temperatures that would instantly freeze any surface puddle. These liquid veins and chambers become the neighborhoods of the microbial cities, creating a network of habitable spaces that thread through the ice like the subway tunnels beneath a great city. The water in these microscopic spaces is not ordinary water. It is a concentrated brine, rich with minerals and salts that have been excluded from the ice crystals as they formed. This briny solution has a much lower freezing point than pure water, allowing it to remain liquid even in the heart of the Antarctic ice sheet. For the microorganisms that live in these spaces, this concentrated brine is both home and resource, a liquid environment that provides not just space to live, but also the chemical ingredients they need to build their bodies and fuel their lives. The citizens of these hidden cities are unlike any living things you have ever encountered. They are so small that thousands of them could fit on the period at the end of this sentence. Yet they are complete living organisms with their own methods of obtaining energy, building shelter, reproducing, and communicating with their neighbors. Some of them are bacteria that have learned to eat minerals, transforming iron and sulfur compounds into the energy they need to live. Others are archaeancient forms of life that represent some of the oldest lineages on Earth. Organisms whose ancestors may have been among the first living things to emerge in Earth's primordial oceans billions of years ago. What makes these microbial cities truly remarkable is how they have learned to create everything they need from the resources available in their frozen world. In the depths of the ice, where no sunlight has penetrated for thousands or even millions of years, these organisms have had to abandon any dependence on photosynthesis, the process that powers most life on Earth's surface. Instead, they have become masters of chemosynthesis, creating energy through chemical reactions that would seem like alchemy to early human observers. Some of these microorganisms feed on hydrogen gas that seeps up from chemical reactions in the bedrock far below. Others consume methane trapped in the ice from ancient atmospheric conditions. Still others have learned to use the difference in chemical composition between different layers of ice as an energy source, much like a battery uses the difference between its positive and negative terminals to create electric current. These chemical reactions not only provide energy, but also create the warmth these organisms need to keep their liquid neighborhoods from freezing solid. The cities themselves are organized in ways that would fascinate any urban planner. Different species of microorganisms occupy different niches within the ice matrix, creating neighborhoods based on chemistry and temperature. Near the surface, where some solar energy can still penetrate the ice, live communities that have retained some ability to use light. Deeper in the ice, in perpetual darkness, live the chemosynthetic communities that create their own energy from mineral reactions. At the very deepest levels, near the bedrock, live organisms that thrive in the slightly warmer conditions created by geothermal heat from below. These microbial neighborhoods are connected by networks of liquid channels that serve as highways for communication and trade. Organisms in one part of the ice community produce chemical compounds that serve as food for organisms in another part. Waste products from one species become essential nutrients for another, creating cycles of resource sharing that would be the envy of any sustainability expert. Some organisms even produce signaling molecules, chemical messages that they release into the briny water to communicate with their neighbors about food availability, environmental conditions, or threats. To the community, the architecture of these cities is constantly changing as the ice around them shifts and flows. As the great ice sheet moves slowly toward the sea, the microbial communities must adapt to changing pressures, temperatures, and chemical conditions. Some neighborhoods are gradually compressed out of existence as the ice around them consolidates. Others expand as new liquid spaces open up. The inhabitants respond to these changes with a flexibility that allows them to relocate, rebuild, and reorganize their communities over timescales that can span human lifetimes. Some of the most remarkable citizens of these hidden cities are organisms that produce their own light. In the complete darkness of the deep ice, these bioluminescent bacteria create a soft glow through chemical reactions within their bodies. This light serves multiple purposes, may help them process food more efficiently, communicate with other organisms, or even provide energy for chemical reactions that would otherwise be impossible in the darkness. The result is that some areas of the deep ice actually glow with a faint, ethereal light that no human eye has ever seen, creating illuminated neighborhoods in the heart of what appears to be solid, lifeless ice. The diversity of life in these microbial cities rivals that of tropical rainforests or coral reefs. Scientists have discovered hundreds of different species of microorganisms living in Antarctic ice, many of them found nowhere else on Earth. Some of these organisms are so different from surface life that they represent entirely new branches of the tree of life, evolutionary innovations that emerged in the unique conditions of the ice cities and exist nowhere else in the known universe. These communities also serve as living laboratories for understanding how life might exist in even more extreme environments. The conditions in Antarctic ice, the cold, the darkness, the isolation, the reliance on chemical rather than solar energy are similar to conditions that might exist beneath the ice-covered surfaces of moons like Europa or Enceladus. In our outer solar system, the microorganisms thriving in Antarctic ice may be showing us what alien life might look like, how it might survive, and where we might look for it in the cosmos beyond Earth. The ice cities also play important roles in the larger systems of Antarctica. The chemical reactions carried out by these microbial communities affect the chemistry of the ice around them, influencing how the ice behaves, how it flows, and how it interacts with the bedrock below. Some organisms produce acids that slowly dissolve minerals from rock particles trapped in the ice, contributing to the complex chemistry of the underground rivers and hidden lakes you discovered earlier. Others produce compounds that act like antifreeze, keeping their liquid neighborhoods from freezing even as temperatures drop further. The populations of these cities fluctuate with the seasons and with longer-term climate cycles, creating rhythms of growth and dormancy that pulse through the ice like a slow heartbeat. During the brief Antarctic summer, when temperatures rise slightly and more liquid water becomes available, the populations boom and the cities expand. During the long winter darkness, many organisms enter states of suspended animation, slowing their metabolism to almost nothing while they wait for conditions to improve. Some of the most ancient residents of these cities may have been living in the ice for millions of years, passed down through countless generations that have never known any world but the dark, cold spaces between ice crystals. These organisms carry in their genes the history of Antarctica's climate, having adapted over vast periods of time to changing conditions as the continent grew colder and the ice sheet thickened. They are living fossils, in a sense, representatives of life forms that evolved when Antarctica was a very different place, but have persisted by retreating into the microscopic refuges provided by the ice itself. The study of these microbial cities is still in its early stages, with new discoveries being made each time scientists extract cores of ice from different depths and locations. Each sample reveals new species, new communities, new ways that life has learned to persist in conditions that challenge every assumption about where and how organisms can survive. The ice that seemed solid and sterile from the surface reveals itself, under careful examination, to be alive with communities as complex and interconnected as any ecosystem on Earth. As you stand on the surface of the ice sheet and contemplate these invisible cities flourishing in the darkness below your feet, you begin to understand that life on Earth is far more persistent, creative, and adaptable than you might have imagined. The boundary between living and non-living, between possible and impossible, becomes blurred when life finds ways to thrive in spaces that seem too small, too cold, too dark, and too isolated to support any form of existence. And as you imagine, these microscopic communities carrying on their complex lives in the spaces between ice crystals, creating light in darkness and food from minerals, you begin to wonder what these organisms might reveal about the deeper history hidden in the ice itself. What memories of Earth's magnetic past might be preserved not just in the chemical composition of the ice layers, but in the genetic codes of the living things that have called this frozen world home for millions of years. You stand at the edge of a glacial plain. The wind is still. Snow crunches beneath your feet like old paper, as though time itself has grown brittle. Beneath this silence, hidden under layers of ice and stone, something ancient sleeps. You kneel, brush frost from a jagged rock, and press your palm to its cold surface. It hums faintly, not with sound, but with memory. This is no ordinary stone. It is a timekeeper, not of years or centuries, but of Earth's magnetic heart. Long ago, when this rock was still molten, floating deep in Earth's belly, tiny grains of iron inside it spun and swirled. They danced freely, like dust in sunbeams, and then they froze. The lava cooled. In that cooling moment, each grain pointed itself in a direction, toward magnetic north. Not today's north, but the north that once was. And so the rock remembered every lava flow, every volcanic breath that hardened into basalt, carried within it a quiet imprint, a frozen compass, not drawn in ink or etched in stone, but encoded in the way atoms align, shoulder to shoulder, within the crystal lattice of minerals. You hold the stone now, not as a weight, but as a whisper, a fossil of direction. Earth's magnetic field is not fixed. It drifts, it wobbles, it flips. Sometimes slowly, sometimes dramatically. North becomes south, and south becomes north. A cosmic coin toss, played over hundreds of thousands of years. No one knows exactly why, but the rocks remember. Geologists call it paleomagnetism, the study of ancient magnetic fields recorded in stone. It's as if the Earth has written a diary, one entry at a time, in volcanic ink. Each rock formation, each ocean ridge adds a page. You picture mid-ocean ridges like giant zippers on the seafloor, pulling the planet apart. As magma spills out and cools, it locks in the magnetic field of the moment. Stripe by stripe, mirror-image bands spread across the ocean bed, recording magnetic reversals, black and white, north and south, like geological Morse code. And still, the rocks remember. Even in the oldest mountains, hidden under ice sheets and forest roots, iron minerals carry the ancient signatures. They point not to where the pole is, but where it once was, a map of shifting certainty. The planet is restless. Its magnetic field bubbles up from deep within, born from the churning outer core, a sea of molten iron and nickel spinning around a solid center. This movement creates an invisible halo, a force that wraps around the world and shields it from the solar wind. You can't see it, but birds feel it. Whales navigate by it. And at one point, Perhaps long ago, even humans sensed it. You wonder, did early travelers follow its pull without knowing? Did migrating ancestors dream of invisible rivers in the sky? There are places where the magnetic memory is distorted, magnetic anomalies, where your compass might spin or hesitate. In these pockets, the rocks remember something different, something local, a field out of sync with the larger pattern, a deviation carved in stone. You imagine a rock lying quietly in a riverbed, iron-rich and unassuming, holding in its core the direction of a sky that existed 1,000,000 years ago. What did that world look like? What animals walked its forests? Did the auroras shimmer in different skies, drawn by poles now gone? Sometimes the field weakens, sometimes it flips. In those in-between times, the liminal moments, the Earth becomes vulnerable. The shield that protects the atmosphere thins. Cosmic particles slip through. Some scientists think these times of transition may have left marks, strange mutations, quiet extinctions, sudden shifts in climate. But still, the rocks remain. Still, they remember. You picture them now. Tiny crystals of magnetite, lined up inside a cooled flow of basalt, silent and unwavering. Not moving, not changing, just pointing, telling their truth, patiently, while continents drift and oceans rise. The stone in your hand is quiet, but it tells a story of the deep, of the unseen, of a field that once curled invisibly through air and sea. It tells of a planet with a molten heart and a memory made of metal. And in this moment, here, on the ice, you feel connected to that invisible thread. The Earth does not speak in words, but in alignment. It speaks through the rocks, through the fields that swirl and shift, through the silence beneath your fingertips. And just beyond that silence, something else stirs. A deeper pull, a breath, not of iron, but of heat. Beneath the field's memory waits the fire that made it. You step onto a white horizon that seems to hold its breath. The ice is quiet, but not empty. Beneath your boots, miles of frozen water press down on buried memories, leaves that once rustled, trunks that once drank sunlight, roots that once braided through dark, wet soil. You came here to feel cold, yet the first thing you meet is warmth. A warmth remembered by stone. The forest does not crackle or sigh. It does not sway. It rests, translated into mineral and crystal, each cell replaced, each vein turned to quartz or calcite. Yet the pattern of life remains, rings inside what used to be wood, spirals inside what used to be fern. Fossils are not corpses, they are sentences paused, commas of carbon turned to rock. You run a glove across a petrified trunk and sense a pause in time, not an ending. Once, Antarctica was a green shoulder of Earth. Summer light circled for months, never setting, painting lichens and mosses in a soft, endless dawn. Giant conifers lifted canopies into warm winds. Insects hummed. Rivers wound lazily toward an open sea. You picture it the way you remember childhood summers long, drowsy, saturated with slow time. The ice sheet you stand upon is a later chapter, but the earlier pages are still here, pressed flat, their ink resistant to forgetting. How can wood survive a stone? Think of a sponge dipped in plaster. Water leaves, minerals enter. Over millions of years, the original tissues cleanly exit, molecule by molecule, while silica and iron slip in, holding the structure together like careful artisans restoring an ancient mosaic. The result is a perfect echo, bark preserved in crystal, leaf veins mapped by chalcedony. even spores and pollen hugging their original forms, now harder than any memory. You kneel beside a stump half buried in snow. Its growth rings are wide, evenly spaced. Each ring is a year, each width a weather. You read it like a diary. Wet seasons, dry seasons, years of plenty, years of quiet struggle. Dendrochronology, the science of tree rings, turns wood into a timeline. Paleobotany, the study of fossil plants, turns stone into testimony. Together, they whisper a climate that shifted slowly, then swiftly, like a heartbeat skipping and resetting. You imagine yourself walking through that ancient forest. Your breath fogs, not from cold, but from humidity. The air is thick with oxygen, sweet with terpenes and sap. The sun traces huge circles, and there is no night-tonally degrees of gold. The ground sighs when you step, soft and loamy. Fungi bloom unseen under leaf litter, weaving networks that feed and warn. Birds startle from branches, small lizards flick tails, and somewhere, a river forgets its banks and slides into a swampy spread of life. Now you open your eyes and see nothing but white. The contrast is jarring, like waking from a dream into a blank hallway. Yet the connection holds. The ice is the other side of the same coin. Climate is a dancer, bowing and spinning, moving from warm to warm again. You are witnessing only one position in the choreography. Scientists drill cores into this ice and into the rock below, pulling up slender cylinders of layered time. Each slice contains oxygen isotopes that reveal temperatures, ash layers that reveal fires and eruptions, bubbles that hold breaths of ancient atmosphere. Deeper still, where the drill hits sediment and petrified roots, fragments of leaves and fossil pollen rise to daylight for the first time in tens of millions of years. The laboratory becomes a forest clearing. The microscope becomes a sunbeam, think. A moment about the slow arithmetic of sunlight. Earth's tilt, the stretch of its orbit, the wobble of its spin-deep rhythms. You need not name it and subtract warmth across tens of thousands of years. Summers lengthen, winters soften, then the pendulum swings back. Forests rise where glaciers sprawled. Glaciers return where forests breathed. A metronome of deep time ticks, and trees once kept time with it. In that patience, chemistry keeps. The ledger, carbon moves like a storyteller, passing a tale around a fire. Leaf to soil, soil to ocean, ocean to limestone, limestone to mountain, mountain to dust. Each handoff leaves a ratio, a fingerprint. Dissolve a fossil leaf, and delicate molecules step into solution, announcing themselves lignin, cellulose, sporopollenin, scaffolds that refuse to forget shape. You crouch and picture roots threading peat, slow batteries of carbon, storing the sun's surplus for a withdrawal no one foresaw. Coal seams are compressed swamps. Oil fields are liquefied marine gardens. This petrified grove is another archive structure without fuel, form without flame. It feeds you differently, not with calories, but with coordinates. You begin to navigate by cycles rather than events. Even the ice above keeps memory. Year by soft year, it falls, freezes, compacts. Tiny bubbles trap the breath of vanished summers, whispers of carbon dioxide and methane like letters never mailed. Warm them in glass and they escape with a hiss. Stories spoken at last. In that faint sound you hear air older than language, older than worry, exhaling like a ghost, relieved. You press your ear to a stone trunk, knowing quartz will not carry sap sounds. Still, you pretend. Imagine xylem stretching, phloem sighing, fungi sliding enzymes into lignin. An ecosystem is not a pile of parts. It is a conversation. Here the sentence is paused, punctuation made of silica, but the grammar remains, readable to anyone patient enough to trace its clauses. Somewhere under a drift lies a log with fire scars, charcoal rings captured before petrification. Even ancient forests burned. Flame was a partner, not an intruder, clearing space, opening cones sealed by heat. Catastrophe and renewal waltzed then as they do now. Your breath fogs, reminding you metabolism is a controlled burn, a flame inside your ribs. You straighten, blanketed by pattern, and step toward dark ribs of rock where another layer waits. You hold a piece of fossil leaf to the light. The veins form a branching river, water turned into pattern. Each vein once carried sugars crafted from sunlight and carbon dioxide. A quiet alchemy performed in green rooms without applause. Photosynthesis, the gentle miracle that keeps you alive, leaves no signature that your eyes can see now. But the structure remains, like a footprint after the walker vanishes into fog. There is a tenderness in how the earth stores memory, not flashy, not loud. Fossils hide in stone. Climate hides in ratios of elements. The tilt of the planet, the wobble of its axis, the slow breathing of ice sheets. These rhythms write themselves into mud and mineral. You are reading a language without verbs, a syntax of layers and crystals, pauses and pressures. The forest's story is also a warning. Warm can turn to cold. Abundance can turn to absence. When carbon in the air climbs, plants flourish. When it falls, ice marches. Today, carbon rises again, not from volcanoes alone, but from the fires and engines of your own species. You feel a small ache in your chest, a recognition that you, too, are part of this long dance, and your steps matter. But guilt is not the point of this walk. Attention is to touch a fossil tree, is to feel the span of possibility. Deserts that bloom, poles that thaw, oceans that retreat and return. The earth changes, but never randomly. It follows patterns, sometimes gentle, sometimes jagged, always guided by energy from the sun and the heat within its core. You trace a fern frond turned to stone. Its pinnae are delicate, like eyelashes frozen mid-flutter. Ferns have outlived empires, collisions, extinctions. They thrive in the understory, patient, persistent. In their fossils, patience becomes visibler grace note held for millions of beats, dot near the edge of a crevasse. You see dark bands cutting through the ice dust ash, bits of ancient soil. Within those bands, there might be microfossils, pollen, grains light as breath, still carrying the shape of summer. Imagine inhaling air that once rattled through Triassic leaves. Imagine steam rising from rain-warmed bark, beneath a sun that spun wider circles. You ask yourself, what does it mean for a forest to become stone? Is it death, or a different kind of life? The molecules have changed, but the message remains. The form persists. It is as if the earth refuses to erase certain sentences, even as it rewrites others. Memory, here, is mineralized resilience. The Antarctic fossil forests teach more than climate. They illustrate plate tectonics, the slow drift of continents. Over a convecting mantle, these trees grew when Antarctica hugged other lands in Gondwana, sharing flora with what is now Australia, India, South America. When the plates parted, the forests went with them, like photographs tucked into moving boxes. Today you find similar petrified woods scattered across distant shores, matching puzzles across oceans. You close your eyes and listen under the silence. There is no birdsong now, but there is the soft crack of ice adjusting. There is no rustle of leaves, but there is the murmur of katabatic winds rolling down from the plateau. The music has changed instruments, not melody. Energy still moves. Water still cycles. Carbon still flows from rock to air to water to organism and back again. Far below, the ground stores more than forests. There are seeds, spores, and bits of DNA locked in permafrost like time capsules. Some are revived in laboratories, coaxed back into metabolic warmth. A moss that slept for centuries awakens in a petri dish. A nematode wiggles after 30,000 years. The boundary between stillness and motion is thinner than the ice suggests. You wonder if a future traveler will stand where you stand and read your world in residue. Plastics layered like new strata, metals scattered like a metallic pollen. What will they think of your forests, your cities, your traumas and triumphs? Will your asphalt become jasper? Will your paper become shale? Will your voice fossilize in some medium not yet imagined? The snow begins to fall, slow and soft. Each flake is a crystal memory of a cloud's cold breath. They land on fossil trunks, on your coat, on the open notebook in your hand. You watch them melt, turning from lattice to liquid, from sharp to soft. Change is constant. Form is negotiable. You tuck a small sample into a padded box, not as a trophy, but as a question. What else lies here, patient and instructive? How many summers are hidden under winters? How many warm rivers slept beneath these glaciers, carving tunnels in silence? The past is not gone. It is layered, like frost, like rings, like stories. You stand and feel the ground, the weight of ice, the thinness of air. You breathe slowly. You thank the ancient trees for holding their shapes long enough for you to find them. You thank the minerals for their careful copying. You thank the quiet for letting you listen. The horizon blurs as snow thickens. Your steps back toward camp are steady, deliberate. Behind you, the fossil forest remains, unbothered by your presence. Ahead, something else calls not the memory of life, but the energy that makes memory possible. Heat, pressure, motion that never fossilizes because it never stops. Beneath the stone trees, deeper than the frozen soil, the planet's inner engines turn, iron flows, mantle rocks convect, plates slide, volcanoes bide their time. If fossils are the Earth's library, the core is its heartbeat. You feel it now, like a distant drum. You pause, snowflakes resting on your eyelashes, and listen. With more than ears. The forest is frozen, yes, but the world is not. The dance continues. The tempo shifts. You are part of it. A brief measure in a symphony too grand to end. You whisper a promise to remember what the rocks remember, to listen when the ice speaks, to notice when warmth returns where cold once ruled. Then you turn, following a faint glow on the horizon, where the next mystery waits like a door ajar. You stand on a vast plain of ice, where the horizon is an unbroken line of white. The sky is pale, almost the same color, and the only motion is your breath, puffing in soft clouds before your eyes. Here, the ice is heavy, not weight you feel in your arms, but weight that gathers in your bones, in the very center of the planet. This is the silence of pressure, a silence so deep it reshapes the world. Each winter, snow falls in gentle layers, like whispered secrets. Over years, centuries, millennia, those whispers accumulate. Snowflakes compress under their own weight, turn to fern, then transform into solid ice. Layer upon layer, the sheet grows thick thousands of feet, miles high. This frozen river flows not with water, but with the force of gravity, creeping outward from the center of the mass, smearing the land beneath like soft clay. Beneath your boots, the ice moves, but imperceptibly. You might visit this place for years without noticing. A glacier slides forward a few feet each year, carving U-shaped valleys in stone. Ice streams surge and stall, riding the whim of temperature and meltwater beneath. Yet the weight never sleeps. It sees all time at once. Pressing endlessly under this blanket, the crust yields. Mountains shrink, valleys lift, rocks flow like putty in a kiln. The lithosphere bends under the load, sagging in basins and bulging at edges. It is called isostasy, dance of buoyancy between crust and mantle. Imagine a mattress with a heavy suitcase on it. The foam compresses under the case, then springs back when the case moves. The earth behaves the same, just far more slowly. You imagine an ancient land green, alive, teeming with moss, ferns, birdsong. Then ice arrives like a vast white tide. Trees snap like matchsticks. Rivers freeze. Animals flee or vanish. The world turns muted, a monochrome of ghosts. But life endures. At the edges, underwater currents carry warmth. Microbes cling to rock. Algae bloom beneath kilometers of ice in hidden lakes. Geophysicists peer into this hidden world with waves, sound tickles, send through rock like gentle knocks on a door. Echoes return, revealing subglacial topography, mountain ranges buried deep, lakes sealed under weight. The echoes also measure pressure. As ice thickens, seismic velocities change. The earth records the load like a barometer, whispering back. Measurements invisible to the eye. You kneel and touch the ice. It feels smooth, solid, yet it is alive with stress. Tiny cracks, called crevasses, mark where tension exceeds strength. They open like silent scars, revealing blue depths where light filters in magical hues. The deepest crevasses are like cracks in a frozen mirror, reflecting the gravity pulling it apart. Even the air above changes under weight. High-pressure weather systems form when ice domes crowd the atmosphere. Winds swirl around the sheet, bringing cold outflows called katabatic winds, rivers of air slipping down slopes under gravity's hand. They roar like distant seas, carrying the chill of the ice into coastal plains below. You listen for that roar, but today the wind is hushed. The silence here is not emptiness. It is compression sound waves squeezed until they cannot move. A whisper would vanish in this stillness before it reached a foot from your lips. Even wildlife is silent. Snow petrels rest in crevices, feathers puffed to trap warmth. Weddell seals nap under ice holes, oblivious to the weight above, but deep beneath, something else stirs. Under immense load, rock reheats and flows. The mantle beneath the crust is solid rock creeping in convective currents. Where weight presses down, rock moves away. Where weight lifts, rock rises. This slow convection is the Earth's heartbeat. Pulsing over eons, you think of the last ice age, when the Laurentide and Fennoscandian ice sheets pressed down over continents. Sea levels fell as water locked in ice, exposing land bridges. Human ancestors walked plains now submerged. Then the ice retreated, crust bounced back, seas rose again, flooding valleys, reshaping coastlines. Today, Land still lifts where ice vanished, gaining inches per century in a silent rebound. You stand on what was once sea floor, now raised high above the waves. You wonder what stories that ancient seabed could tell, fossils of fish entombed in sandstone, ripple marks frozen in stone, shells turned to calcite sculptures, all because ice pressed down elsewhere, shifting mass and tilting countenance. Even here, the weight of ice writes records. Ice cores are cylinders of frozen time, each band a page in Earth's journal. Scientists extract them, counting annual layers like tree rings. They measure trapped air bubbles to read ancient atmospheres. They analyze isotopes to gauge temperature. They find volcanic dust telling of eruptions, microscopic particles revealing desert storms halfway across a continent. These cores speak of rapid climate events, sudden warmings, abrupt coolings, like the Younger Dryas, when temperatures plunged in a heartbeat of geologic time. They speak of more gradual shifts, the ebb and flow of carbon dioxide over glacial cycles. Each breath you exhale is part of that story, a fleeting echo of ancient gas cycling. You cup a handful of snow, let it melt on your glove. Each drop is water reorganized, its bonds shifted by temperature and pressure. Soon it may percolate through. Crevasses lubricate the base of the sheet, speed the ice's flow. A molecule of water lives many lives: river, glacier, ocean, vapor, cloud, over and over. A hydrologic waltz. You rise and look to the horizon, where the ice curves down toward the sea. In some places, glaciers terminate in calving fronts, cliffs of ice breaking off into icebergs. You imagine those icebergs drifting into open water, carving channels, grounding on shoals. They carry the memory of pressure with them, riding the current to melt at their pace, redistributing mass. This weight is not static, it moves. Climate softens the edges, adds warmth, invites melting. Water seeps to the base, carving tunnels and caves, hollowing the ice from beneath. The sheet sings with hidden rivers, whose murmurs travel through channels, sometimes erupting in sudden floods that reshape landscapes in hours. You listen for that murmur, but here on the surface, the silence holds. You close your eyes and imagine the ice as a vast living organism, breathing in snowfall, exhaling meltwater. Its heartbeat is imperceptible, but you feel it as a pull in your chest, a gentle tug at your center of gravity. Gravity itself changes. Here, the mass of ice depresses the gravitational field, creating tiny variations. Satellites measure these with exquisite precision, mapping the gravity anomalies over polar regions. Scientists translate them into ice thickness, mass balance, and changes over time. Each measurement is a snapshot of weight, telling whether ice grows or shrinks. You pull a small GPS device from your pocket and check your location. Even here, technology tracks your position, relying on satellites that correct for gravitational pull. Your precise spot is known to centimeters as you stand on the shifting sheet. The ice moves, and you move with it, coasting along on gravity's conveyor belt. But beyond these instruments, you have simpler tools, your senses. You notice posture differences on slopes, subtle changes in snow texture. You watch shadows lengthen. On ice mounds, you feel sweat freezing on your brow, reminding you of the delicate balance between heat and cold. Under the weight of silence, you have space to notice. The mind slows, thoughts drift like snowflakes. Each idea lands gently, then dissolves. A single breath expands your awareness. You realize that pressure is more than force. It is focus. Under gravity's tender hand, the world reveals its hidden seams. You imagine the next step, beneath the ice sheet, where heat from Earth's core fights the chill. Temperatures rise with depth. At certain points, ice meets rock at the pressure melting point. Water films form, sculpting the base, enabling the sheet's slow slide. This internal warmth shapes flow, affects stability, shapes tides of ice. Here, on the surface, you stand on the threshold of weight and warmth. The white silence holds you, quiet as a question. Pressure bends rock, heat bends ice. The two forces meet below, where physics weaves its finest tapestry. You take one last look at the frozen plain. Heart, mindful of its gravity, you step toward a ridge of blue ice, where the next story awaits an encounter with fire beneath frost. Where the Earth's molten pulse meets the glacier's patient advance, you step into the mouth of the ice cave. A hush falls, deeper than any forest or desert. The air is cool and still, as if held in suspension by the walls themselves. Light from your headlamp glints off crystal columns, shafts of pale blue and green, like stained glass windows in a cathedral of frost. You move slowly, each footstep barely more than a shift of weight, mindful not to disturb these silent architects. The cave breathes in rhythms locked to seasons you cannot perceive. In summer, meltwater seeps through crevasses above, trickling down to build hidden rivers that sculpt the interiors. In winter, refreezing halts the flow, adding new layers of ice like plaster to a fresco. Over centuries, these cycles carve chambers, and galleries wide enough to shelter storms, tall enough to cradle the sky. See how the walls curve. They are not smooth, but striated with lines, annual bands of clearer and more opaque ice. Each line is a record of a year's melt and freeze, like the growth rings of a tree. You press your fingertip to one band and feel a subtle ridge. In that tiny ridge lies a season's worth of sunlight, captured and stored in the lattice of water molecules. Ahead, a great hall opens. Pillars of ice rise from the floor, tapering upward to meet vaulted arches overhead. They sparkle under your light, their facets refracting beams into fractures of color. Hues of turquoise, emerald, and sapphire dance on the walls, shifting as you walk. The physics is simple light, slowed and bent by density differences, but the effect is sublime. Here, science becomes art. You reach a pool, dark as obsidian. Its surface is mirror flat, reflecting the cathedral above in perfect symmetry. You kneel and peer into its depths. Tiny bubbles cling to submerged pillars, trapped during formation, each bubble a story of a moment when water froze. Faster than it could expel gas. Some bubbles form veils of frost, others hover like suspended lanterns. You imagine them as lanterns guiding your path through the darkness. Delicate sculpture arches over the pool, a frozen ribcage of ice modules, each curved like the spine of some ancient creature. You trace the geometry with your eyes, noticing how each segment tapers precisely, how gravity and surface tension conspire to yield these elegant shapes. When meltwater drips from a stalactite, it draws a thin string of freezing water downward. In that moment, the water's surface tension fights gravity, holding the drop in place before it falls and crystallizes. In stillness, physics sculpts. As you step away, your boots whisper on the smooth floor, stirring no more than a breath. You follow a narrowing corridor, walls closing in until the passage is barely wide enough to squeeze through. Here, the ice grows clear as glass. No air, no impurities, only solid water. You touch the wall and see your hand's outline magnified, as though beneath a lens. The purity of ice here is the result of slow, steady freezing impurities pushed outward, air bubbles forced aside, until the ice is nearly perfect. On the far side of the corridor, you emerge into another hall, broader and higher. Here, the ceiling arches like the inside of a giant seashell. Underfoot, the floor slopes gently downward. In the distance, you spot a faint glow natural light entering through a thin ceiling at the cave's crown. Sunlight filters in, casting a pale halo that pulses as clouds drift overhead. Each cloud shadow shifts the glow, turning the entire chamber from dawn to dusk. You walk toward the light, drawn by its quiet pulse. Along the way, you pause at formations that look like frozen curtains, thin sheets of ice, undulating as if billowing in a wind you cannot feel. These ice draperies form where water flows over a surface, then freezes in place. They are fragile, luminous, and reach their final form only after countless cycles of flow and freeze. You imagine them rippling in some subterranean breeze, but they are as still as the cosmos. A large column stands before you, wider than any tree trunk you have known. Its base is surrounded by concentric rings of Issa fountain frozen mid-gush. You wrap your arms around it and feel a smooth chill seep through your jacket and gloves. The column is warm compared to the wall's warmer, because it channels the residual warmth from the ground below, where geothermal heat percolates upward through cracks. You can feel that warmth as a gentle hum, a reminder that this ice palace floats above a living planet. You take a deep breath and let your eyes wander upward. There, overhead, a network of micro-cracks branches like leaf veins. Each crack once formed when the ice flexed under its own weight, or when meltwater intruded, then froze. Over time, the cracks widen, heal, and widen again, weaving a tapestry of lines that you could spend hours tracing. These cracks conduct sound differently than solid ice. If you tap the surface, you hear a crisp ping that resonates, as though the cave itself is speaking. You tap lightly on the wall. The sound ripples sharp at first, then muted like a soft bell fading into memory. Silence returns, but now you notice a different quality. A low hum, barely above inaudible, vibrating through the floor. It is the cave's heartbeat, the distant roar of water flowing in hidden channels. The slow flex of ice under gravity, the echo of shifts and fractures. Far away, you stand still and listen until your ears match the cave's pulse. Moving on, you crest a small rise and find yourself in a chamber illuminated by a shaft of ethereal light. Dust like crystals drift in the beam, sparkles that dance like fireflies. In the golden shaft, you hold your hand in the light and see each crystal as a tiny prism, splitting the sunbeam into miniature rainbows. You cup your palm and catch one. It melts instantly, leaving a bead of water that glows in your hand before trickling away. Here, the cave's scale shifts. What seemed cavernous before now feels intimate, like a private chapel. You bend low to inspect a cluster of ice stalagmites, short, squat columns rising from the floor. They form where water drips from overhead, pooling and freezing layer by layer. Each layer adds mass, each pause in dripping adds time. Some stalagmites are ringed with color, faint bands of dust carried in by wind and trapped between freeze cycles. They are geological timekeepers, each band a day or week's worth of meltwater. You lie on your back on the icy floor, staring up at the ceiling of crystal. The world feels suspended, as if you lie beneath a dome of glass spheres. Each crystal facet catches light from different angles, making the ceiling shimmer like a constellation. You imagine yourself afloat in a sea of stars, drifting weightless among frozen nebulae. A soft breeze brushes your cheek. You sit up and follow it to a narrow fissure high on the wall. Through the fissure, you glimpse the outside world, the sliver of blue sky, a hint of snowfields. The cave remains hidden behind a thin curtain of ice. Only light and wind penetrate. It feels like a secret shared between the cave and the sky. You rise and move toward the fissure, leaving behind footprints that will soon be erased by drifting snow. At the threshold, the cave narrows to just wide enough for you. You squeeze through, brushing against walls that hum with cold. On the other side, you step into a third hall, this one hung with icicles like a fringe of chandeliers. They dangle from the roof, some as slender as threads, others as thick as ropes. The longest plunge several meters, trembling slightly as warmth from your body stirs the air. You walk beneath them, careful not to strike one. Each icicle is a record. Water froze at the tip, then froze again further up, repeating until gravity overcame attachment. The cross-sections of icicles are often triangular nature's way of balancing surface tension and flow. You touch one gently. It quivers, and a bead of meltwater drips to the floor, joining a pool that swirls and drains unseen. Ahead, the floor slopes downward toward an opening too bright to look at directly. You shield your eyes and approach. As you near, the air grows warmer, more humid. You hear running water steady, lively, joyous. You step into the opening and find a waterfall of meltwater pouring through a gap in the ice. It glows in the light, a ribbon of sapphire moving endlessly. You press your palm into the flow. The water is cold, yes, but carries vitality, a living current escaping from the cave's heart. You follow the water downstream, watching as it carves channels in the ice. Some channels widen into pools, others narrow into tunnels. The sound of water is melodic here, a lullaby that harmonizes with the cave's stillness. You feel its rhythm in your chest, matching the pulsing hum you heard earlier. The passage opens again into daylight. You step out into a snowy slope, the sun low on the horizon, painting the snow in pastel hues. You turn back to look at the entrance. You came through. It is a dark mouth, fringed with icicles, promising more wonders within. You pause and breathe deeply, filling your lungs with the crisp air. Around you, the landscape is silent, dominated by white shapes and the glow of ice. Yet in your mind, the cave continues to resonate the geometry of light and shadow, the slow craftsmanship of physics, the gentle music of melt and freeze. You realize that these crystal cathedrals are both fragile and enduring. They hold their form only so long as conditions allow. A rise in temperature, a shift in the wind, a change in precipitation, all can alter them irrevocably. Yet as long as they exist, they stand as monuments to pattern and possibility, to the quiet artistry of natural law. You turn to leave, feeling the pull of the next discovery. Beyond this icy shrine lies new terrain, the edge where ice meets rock, in a dance of friction and flow, where glaciers carve valleys and deposit moraines. There, the story of ice continues in shapes bolder and coarser ridges and fields of broken ice. You stand at the lip of a glacier, where the ice surrenders to rock and earth. It is a threshold between two worlds, the still stone of the mountain and the flowing crystal of the ice. Before you stretches a river frozen mid-ballet, Its surface rippled like beaten metal, its edges scalloped into archways and wavelets. You feel something deeper than cold under your boots, the pull of gravity steering the ice in a movement, so patient you might not notice it without your full attention. Glaciers flow, not like water, but like honey in winter slow, viscous, unstoppable. Under their own weight, the deepest layers begin to yield and shear, inching forward where fronts carve into icebergs or retreat into meltwater pools. This motion is called creep, and it happens because ice, at sufficient depth, behaves more like a plastic than a solid. You imagine microscopic grains slipping past each other under the immense load, rearranging themselves ever so slightly to carry the mass along its gentle slope. The path of the glacier is guided by the shape of the land valley's channel. Its movement, ridges redirect it, basins hold it in place. As you peer down the length of the ice river, you notice bands of blue where the ice is thickest and purest. Their bubbles have been squeezed out, leaving behind solid water so dense that it absorbs red light and reflects blue. Other bands glow white, full of air and fresh snow. Together, these stripes form a barcode of climate history, each layer marking a season of snowfall or melt. You trace a meandering line of dark debris on the ice's surface, a medial moraine, where two glaciers once converged, their rock-laden edges merging into a ribbon of stone. These rocks and dust, carried from bedrock hundreds of feet below, ride on the ice like passengers in a silent procession. Some are jagged shards torn loose by frost, others are rounded pebbles smoothed by centuries of grinding. You bend to pick one up. It is warm from sunlight, yet you can feel the memory of pressure etched in its fractures. Beneath your feet, the glacier is alive with hidden water. Melt from the surface percolates through Milan's vertical shafts, drilled by summer, warmth feeding subglacial rivers that surge and subside. Where water lubricates the bed, the ice can accelerate, sliding more freely over rock. Where water drains away, it slows, clinging to the contours of the ground. This interplay of friction and flow gives the glacier a pulse. Periods of surge, periods of rest, all measured in years rather than days. You step onto a ridge of till-glacial sediment deposited at the ice's margin. It is a coarse mixture of clay, sand, and boulders, heaped in rolling hills that mark past positions of the ice front. Each hillock is a memory of where the glacier paused, gathering its load before pressing on. Here, the land whispers of cycles, advance and retreat, build and erosion, creation and destruction. You feel tiny in this landscape, yet woven into the same rhythm. High above, Seracs towers of jagged ice rise like frozen skyscrapers. They form where the glacier negotiates. Steep terrain, breaking apart under the strain of gravity. Some stand solitary, slender spires. Others cluster in chaotic forests of ice. You imagine them fracturing in a thunderous collapse, but for now they remain motionless, stalwart sentinels guarding the glacier's path. The language of ice is written in crevasses, deep yawning cracks that open where the ice stretches. Their walls are striped with bands of layer after layer, each band a season frozen in place. You peer into one and see its depths fade to pale blue. In the echo of your voice, you hear centuries, the sigh of ice shifting, the whisper of ancient snow, the murmur of distant rock. You follow a lateral moraine along the glacier's edge, where debris from the valley walls has fallen onto the ice. These moraines feed rockfall into the ice, shielding parts of the surface from sun and slowing melt. In the shaded grooves between debris and ice, Small pools of water gather in summer, reflecting sky and mountain like secret mirrors. You pause to look at one. Its surface is glass, its bottom littered with silt and pebbles, its edges crowned with thin ice rafts. Above you, the glacier catches sunlight and glows. Where the ice is thin, veins of dust stain the surface, turning it silver grey. Where the ice is thick, it hums with muted light. You reach out your hand, feeling the chill seep into your glove. It is a reminder that this movement, though slow, carries vast power, the power to carve valleys, to grind mountains, to shape the world. You walk to the head of the glacier, where snowfields feed the ice stream. Here, accumulation outpaces melt, building new layers each winter. The snow is soft, each flake a crystal memory of a storm. You step in and feel the give beneath your boots, the way fresh snow yields then holds. You lie down and press your ear close. You hear nothing but the faint settling of grains, a hush that speaks of millions of flakes added one by one. Now you rise and turn back toward the ice. You notice how the glacier's surface curves downward, inviting gravity to continue its work. The flow is inevitable, a consequence of mass and slope. You imagine it as a dance, slow, deliberate, three-step, accumulate, compact, flow. Step by step, the glacier moves, carrying its cargo of rock and dust across the continent. In your mind, you convert distance into time. A mile of flow might take a century. An inch of melt might represent a summer's warmth. You think of the people who measured flow rates with stakes and GPS, who drilled ice cores to read temperature, who mapped the bedrock beneath with radar. Science enhances the poetry, giving language to the rhythm you feel but cannot see. As you descend the glacier's face, you come to a proglacial lake where meltwater pools behind a wall of ice and moraine. Its surface is bright blue, an electric color, born of finely ground rock powder called glacial flour. You peer into its depth and see sediment swirling, carried by sebaceous currents. You drop a pebble and watch ripples spread, each circle an echo of the glacier's motion. You kneel and touch the water. It is alive with movement, though you feel only a gentle brush of current. You imagine it flowing under ice, through tunnels, into rivers that nourish valleys below. The glacier's influence reaches far beyond its edge, feeding ecosystems and human communities alike. Its slow dance is a lifeline, a reservoir of fresh water, a sculptor of landscapes. You stand and look back at the glacier, its white-blue mass receding into the distance. You feel gratitude for its patient work, for its lessons in time and scale, for the way it humbles you and fills you with wonder. The world is vast, and yet here, in this quiet flow, you grasp something intimate that change need not hurry to. Be profound. With careful steps, you leave the glacier's margin and head toward a ridge of bedrock where you will camp. There at dawn, you will watch the sun strike the ice, turning it to gold. You anticipate the next chapter of this journey, where fire meets stone, where volcanic heat challenges winter's rain, and where the earth's inner fire writes a new verse in this endless story. You step onto the edge of a snowfield, crisp and boundless. The air is thin, yet beneath your boots lies a world richer than the white stillness suggests. Here, under miles of ice, the earth's liverets, molten heartbeats with a steady rhythm. You press your palm into the snow and feel warmth, not from sun, but from below. This warmth is subtle, carried upward through veins of rock, a reminder that cold is only skin deep on our living planet. Imagine magma rising in secret corridors, carving tunnels in the bedrock, gathering in chambers like whispered conspiracies of heat. The ice above is a grand lid, sealing pressure in place, trapping the steam that bubbles off hot rock. Where the magma has drawn too near, the ice softens, melting into subglacial lakes and rivers that meander in darkness. These hidden waterways are lit by phosphorescent bacteria, tiny lanterns in the deep, feeding on minerals leached from volcanic rock. You close your eyes and picture the contrast: ice above, magma below. One solidifies slowly, the other flows slowly. Both follow the laws of physics, but one yields to cold and one to heat. In places where they meet, a delicate balance forms. Steam rises in misty plumes, carving caverns of obsidian and glassy stalactites. A frozen vapor. These caverns are crystal cathedrals where water and rock dance an age-old waltz. The science here is gentle alchemy. Water from melting ice seeps into cracks in the hot rock, flashes to steam, and acid etches the walls, releasing silica and metals. When the steam cools again, it deposits these minerals as vein quartz, chalcedony, even gold in tiny veins that sparkle under headlamp. You kneel to inspect a seam of milky quartz embedded in dark basalt. It glows softly, as though holding a sliver of sunrise dot around you. The ice groans under pressure. Crevasses open where speed picks up, where basal meltwater lubricates flow. The glacier is alive above the volcanic chamber, moving with its own slow grace. You imagine the interplay. Magma thaws ice, meltwater quickens flow. The glacier advances, grinding rock into flour, which then feeds subglacial rivers and returns to the sea. It is a closed loop, an ecosystem powered by heat and sculpted by cold. You walk toward a hissing sound, subtle at first, then insistent. Steam vents hiss through fissures in the ice, like a distant chorus tuning before a song. You place your palm near a vent. The warmth is immediate, a gentle burn. Bacteria cluster here, bright orange mats glowing in the steam. They metabolize sulfur and iron, creating microhabitats that defy the cold above. In these pockets, life thrives on chemistry rather than sunlight. You crouch by a thermal spring trickling across ice. Its water is clear, mineral-rich, tasting faintly of earth and metal. You dip your fingers in and feel energizing warmth. Close your eyes and you can almost hear the stones pulsing your rich basalt, heated by great depths, slowly releasing energy as it cools. This is earth breath, the exhalation of a planet whose core never sleeps. Currents chart courses you cannot chart, weaving your frozen world into a tapestry of liquid motion. You walk across a plain of blue ice, the wind combing crystals into faint ripples, and a small dark stone stops your stride. It does not match the mountain behind you or the nunatak ahead. It seems to have dropped from a different sentence in Earth's story. You kneel, brush frost away, and feel a chill that is not the air's an ancient cold, the kind that drifts between planets. Meteorites. Love this continent for reasons that sound like fate. Snow falls, compacts, becomes ice, and flows outward like a slow glass river. Anything trapped within rides that flow until katabatic winds scour the surface clean, polishing blue ice fields like mirrors. Dark fragments gather there, concentrated by motion and light, standing out against the pale. Antarctica is a cosmic sieve, a patient curator, a museum case left to the sky. You lift the stone. It is heavier than you expect, a pocket of density. You can weigh, its surface is fusion, crust melted, glassy, browned by atmospheric entry, like charcoal toast. Tiny pits, called regmog lips, dimple it where air carved thumbprints during its plunge. Inside, it may hold nickel and iron, minerals aligned like compass needles, frozen during a different solar breeze. Or perhaps it is a carbonaceous dark with primitive organics, water locked in clays, preserving whispers of prebiotic chemistry. You do not know yet. Holding is enough. You feel the stone like a heartbeat borrowed from space. Each meteorite is a letter with no return address, stamped by shock veins, written in isotopes, sealed in time. Scientists slice thin sections, polish mirrors of metal, dissolve acid-soluble phases, tease out noble gases to read ages measured in half-lives. But before all that, there is this momentary breath fogging around an object that crossed vacuum, burned through air, and waited in ice for hands. The story of its journey begins far away. Maybe it broke from an asteroid in the belt between Mars and Jupiter, torn loose by a collision in the gravitational tango of countless stones. Maybe it came from the moon, kicked free by an impact that flung shards across space like sparks. Some even carry Mars in their cores, wind, scoured basalt packed with bubbles of ancient atmosphere. Wherever they start, fragments wander for eons, perturbed by sunlight, tugged by resonances, guided by the slow choreography of gravity and resonance. You imagine that plunge, the sudden flare, air screaming as molecules ionize, the body shedding heat and speed, shedding mass until only a kernel survives. It slams into snow or skids across ice, sinks a little, cools, and then vanishes under storms. The glacier takes it, hides it, migrates it, and finally offers it back on a polished stage. You arrive at the right hour in that long play. Antarctica's dryness helps. Little liquid water means little rust. Cold slows chemical whispers. Rocks here can wait tens of thousands of years without losing themselves. When the sun arcs low, these stones warm slightly and sublimate pits in the ice beneath, making pedestals so they stand higher, easier to see. The continent is kind to messengers. You slip the stone into a padded pouch. Later, in a warm tent or a distant lab, you will read it like a diary you cannot quite pronounce. In thin section, chondrules will gleam tiny spheres, once molten droplets, floating in the solar nebula, frozen mid-spin. Calcium aluminum inclusions, the oldest solids, will sit like punctuation marks. Iron phases will reveal slow cooling deep in a parent body. Shock veins will tell of violence pressure waves that stitched minerals into glass in millionths of a second. You breathe slowly. The cosmos is not elsewhere. It is here, in your glove. Stardust is not metaphor. It is literal, granules, older than Earth, layered in these stones, immune to the solar furnace, carrying isotopic signatures from ancient supernova. Silicon carbide grains whisper of distant giants. Tiny diamonds form in impacts more intense than anything we can stage. These are souvenirs from furnaces and collisions no human eye has seen. You look up. The sky is a blue so deep it feels hollowed. The sun glints off sastrugi, and the wind writes low music over the snow. In that music you hear distance. You remember that everything you are, the iron in your blood, the calcium in your bones, was forged in stars. Holding a meteorite is like shaking hands with ancestry, the family reunion of elements. Not all visitors are large. Micrometeorites, the size of dust, fall constantly. Billions tumble through the atmosphere each day, soft as soot, settling on ice, roofs, oceans. In Antarctica, scientists melt snow filters and sift dark specks under microscopes, finding tiny spherules with magnetic soles. They are planetary confetti, sprinkled by comets, shedding tails, by asteroids spalling flakes, by worlds grinding down. You think of them as the universe's dandruff, humble and ubiquitous, yet telling. The ice itself traps even finer things, cosmic rays that carve tracks in minerals, solar wind implanted in lunar grains, later found in Antarctic samples. Some meteorites contain amino acids, left-handed and right-handed, hinting at chemistry's early games. Others hold water, not liquid but locked in structure, a thirst-quenching clue for how oceans may have grown. You let these facts settle like snowflakes on your mind, melting into understanding at their own pace. You walk farther, eyes scanning for dark flashes. Flags mark previous finds, bright bits of cloth fluttering like prayers. Teams fan out methodically, gridding the field, recording GPS points, logging weather, noting ice texture. Every stone is bagged, barcoded, biopsied by protocols refined over seasons. It is ritual as much as research, reverent in its repetition. You pause by a wedge of blackened rock half embedded. Its shape is aerodynamic, a teardrop frozen mid-flight. Perhaps it is a sugartite from Mars, its minerals holding argon that matches the red planet's air. Perhaps it is an H-chondrite, everyday cosmic gravel. You do not know. Uncertainty is not failure. It is invitation. Nearby, a cluster of smaller fragments glitters. A meteorite rarely falls alone. Showers scatter siblings across kilometers. You collect them gently, imagining their reunion in a tray back at base. Each piece will confirm or complicate the other's stories. Together, they reconstruct an impact, a parent body, a timeline. You think of the first discoveries, explorers stumbling on dark stones and pocketing them as curiosities. Only later did systematic searches begin, when glaciologists and planetary scientists realized the physics of ice could focus meteorites. Since then, thousands have been found. Some common, some rare jewels, some rewriting histories. Names like Allen Hills, Yamato, Miller Range echo like constellations in grant proposals and papers. The wind rises, curling drift around your boots. You tuck your scarf tighter, not against cold alone, but against the sense of scale, holding space. Rocks makes your heart expand with equal force. Awe at the breadth of time, comfort in the tangible weight of a single stone. You feel both enormous and small, like a neuron firing in a cosmic brain. You recall that a meteorite once suggested life on Mars. Isle the Lepen Pulumput, with carbonate globules and wormy textures. Debate flared, cooled, lingered. The stone kept quiet. Its carbonate still sits there, unchanged by arguments, patient as basalt. Science, like ice, moves slowly, sometimes surging, sometimes pausing, but always flowing toward clarity. You run a thumb over a fusion crust ridge. It flakes slightly, revealing metallic sparkle. Part of you wants to break it open, to see inside, but respect stays your hand. There is a time for holding, a time for slicing, a time for dissolving. For now, story is enough. You set the pouch back in your pack and stand, gaze sweeping the horizon. The blue ice glows, a frozen conveyor delivering gifts from above. More stones wait. More secrets hum. You realize Antarctica is not just a window. It is a net spread wide, catching stones so they cannot hide in soil or sink in oceans. You are standing on the planet's catch basin for starlight made solid. Walking on, you consider meteor showers. You have watched Perseids, Gemini's silver threads, across summer skies. Those are dust trails, remnants of comets unraveling, painting Earth's atmosphere with fleeting fire. Some survive, most don't. But down here, the survivors gather, patient as monks copying the universe's scriptures. Science will take your stones and measure oxygen isotopes to assign lineage, scan with CT to map metal veins, heat samples in vacuum to sniff noble gases, mount grains in epoxy to laser off atoms for mass spectrometry. Each technique is a key, each element a word. Together they tell where, when, how. Together they remind you knowledge is built like glaciers, flake by flake, layer by layer, pressure making coherence. You picture the stone's parent body cooling, its core crystallizing metal, exsolving sulfides. Impacts crack it, shock metamorphism resets clocks, cosmic rays etch spallation nuclides into rims. Then one day, gravity and chance align, and the journey begins. Your fingers are one waypoint. In that saga, brief but tender, you sit on your pack and sip from a thermos, steam curling into polar air. The taste of tea grounds you. Above, the sun does not set. It reels around the horizon, painting the snow in gold, then rose, then blue. Time here is circular, like orbits, like atom spins. You rest in that circle, breathing with it. Beside you, a Sastrogi ridge gleams. Beyond it, the ice drops into a crevasse field where you will not go. Beyond that, mountains thorn the sky. Beyond those mountains, ocean waits. And beyond the ocean, people sleep under different stars, not knowing a stone from Mars just shifted in your bag. You smile at the secrecy. You brush snow from your knees and stand. Your footprints already soften. Soon wind will erase them, leaving no trace of finder or find. That feels right. The stone will keep its quiet until lab lights replace polar glare, until microscopes become your new horizon. Then, under glass, you will wander again through chondrules and metal blebs, through olivine grains and shock veins, through clues etched finer than any wind line. You head toward camp, the cold seeping now that excitement settles. The pouch presses against your hip, a weight that keeps you tethered. Night will not fall, but you will sleep. Cradle bruises from kneeling on ice, dream of floating between worlds. You might dream of planetary crusts cracking, of iron rain, of protoplanetary disks glowing like embers. Dreams are another kind of thin section, slices of mind under LAMPLIGHT dot at the tent. Your companions log the day's finds, write numbers, SNAP photos. You place the pouch on a clean sheet, nod, step back. The ritual continues. Labels, forms, cold fingers turning pages. Laughter punctuates the method, human warmth rising in a room full of space rocks. Later, lying in your sleeping bag, you listen to the canvas rustle, the stove hiss, the glacier murmur under thick pads. You roll the day through your head like a meteorite under light. Outside, particles still fall, most too small to notice, all part of the same rain. You feel the universe landing softly, constantly, on your skin, your eyelashes, the tense roof. You wonder what the next stone will say. Will it be older than Earth, a grain from a star long gone? Will it be young, from a body shattered recently in cosmic terms? Will it hold water, organics, clues to habitability? Will it be beautiful, a mosaic of olivine and pyroxene that makes you gasp under fluorescence? Questions are constellations. You trace them and feel oriented. You drift towards sleep with one more thought. If ice can keep a meteorite safe for millennia, what could it keep from you? What story of your species will freeze, wait, and be found by distant hands? The stone does not answer. It never needed to. It only needed to arrive, endure, and be seen. The wind hums, the stove clicks, your breath slows. The meteorite rests in a metal box, wrapped and labeled, ready for a journey to laboratories where lasers and magnets hum like distant stars. You feel yourself hum too, a quieter frequency, syncing with ice, rock, and cosmic dust. You close your eyes. Somewhere above, another pebble lights the sky. Somewhere below, another shard inches toward blue ice. The museum is always open. The curator is patient. The collection grows by starlight. You turn once cocooned in down and let the silence become weightless. In that weightlessness, a pebble falls forever. You float beside it, and earth rises to meet you like a slow blue hand. You stand on the last white rise, a gentle swell of seasons pressed into crystal, and feel the sheet beneath you, breathing. The ice inhales snowfall, exhales meltwater, sighs in creaks and hairline pops. It is not dead, you realize. It pulses, shifts, murmurs, an organism of patience whose cells are hexagonal grains and whose blood is water sliding grain to grain. You lay your glove on the surface and sense faint tremors. A heartbeat stretched across centuries. Ice is born the way patience is born, flake by flake, layer by soft layer, each winter tucking another sheet of memory over the last. Fern settles, air is squeezed, bubbles become capsules of vanished summers, and the lattice tightens until the snow becomes something else, transparent, blue, heavy as folded time. Deep below, bubbles hold whispers of mammoth herbs, campfire, smoke, volcanic ash, industrial size. Every trapped breath is a syllable in Earth's long sentence. Movement gives the ice its life. Gravity draws it outward from domes of accumulation, and the sheet flows like a continent of honey, slow, yet unstoppable. Inside, crystals deform and recrystallize. At the base, thin water films let the whole body glide. Crevasses open where tension stretches the skin, then heal under new snow, like scars softened by fresh tissue. Ridges buckle where compression shortens the path, turning the surface into frozen waves. You walk along these corrugations, reading their rhythm as if tracing a score written for gravity and time. Listen closely. Beneath the quiet is sound. Crystals snap as they realign under stress. Basal water gurgles in black tunnels. Lakes fill and drain, lifting the ice by centimeters, then letting it settle like a sleeping chest. Radar pulses ping off hidden mountain ranges, revealing valleys as deep as the Grand Canyon, carved by rivers long gone. Seismic tremors trace icequakes, sparked by sudden slipsteeny quivers, reminding you that stillness here is only camouflage. Life finds niches in this frozen body. Algae bloom reddish on late summer snow, tinting slopes like diluted wine. Bacteria metabolize iron in pressurized lakes, trading sunlight for chemical gradients, thriving on whispers of nutrients leached from rock. Rotifers and nematodes awaken when thin films of water appear, then freeze again into waiting. Dormancy is not death. It is a held breath, a paused violin bow. You think of seeds curled under permafrost, spores folded like question marks, genes, preserved in crystal patience. Sunlight writes over the ice each day, carving melt ponds whose turquoise skins mirror sky. Evening cool refreezes them from the top downward, trapping bubbles in lattice like lace set in glass. Katabatic winds polish facets, sculpt sastruge hard snow fins pointing downwind like teeth. Hoarfrost feathers grow, catch moonlight, and vanish in one impatient gust. Every shape speaks fluent physics, sublimation, deposition, albedo. Conduction verbs, in a language the glacier learns slowly and speaks without hurry. You remember the cores lifted from boreholes, slender cylinders of pale blue time. Scientists slice, log, smell, even listen to them crack as pressure relaxes. Within those columns, isotopes of oxygen and hydrogen sway like dancers, mapping temperatures long gone. Dust layers track distant deserts. Sulfate layers remember eruptions. Lead spikes mark factories' first breaths. The ice is an archivist, impartial and meticulous, saving everything without preference and offering it back to anyone patient enough to ask. Yet the archive edits itself. Compression blurs annual bands at depth. Molecules diffuse. Gases migrate along microfractures. Signals smear into background hum. Even living ice forgets slowly, the way you forget exact words but keep the feeling. Still, enough remains to teach. Enough remains to warn. You read the sawtooth of glacial cycles, the sudden rise of greenhouse gases, the jolt of modern warming. The ice becomes a mirror, and in it you see both ancient air and your own quick breath. Glaciers sculpt as they go, wearing mountains the way sandpaper wears wood. Plucking, abrasion, freeze-thaw, wedging tools of a patient carpenter. Valleys widen, cirques deepen, fjords flood when the sculptor steps back. Moraines mark, pauses lateral, medial, terminal. Punctuation in rubble. Eskers snake like inverted rivers, till spreads like quilts of mixed stones. When ice retreats, kettle lakes appear where stranded blocks melt, and outwash plains sprawl where braided streams once rushed. The landscape is the draft left behind by frozen hands. You kneel beside a cryoconite, hole around pool melted by a pinch of dark dust. Within it, microbes spin silky threads, stirring the water, darkening the pocket further, deepening their home. They are tiny engineers, circling sediment like potters at wheels. Multiply them across a sunlit surface, and you feel how even small lives can quicken, melt in, how feedback murmurs within the body of ice. This organism adapts, responds, modulates. It is not simply a victim of warmth, though warmth presses hard. Far away, shelves, rift and cave, birthing tabular icebergs that drift like floating libraries. Satellites watch them crack. Algorithms measure their speed. Sailors plot their paths as they carry cold stories north, some ground on shoals, creating temporary oases for seals and penguins. Others wander into warmer currents, releasing fresh water that freshens surface layers, altering stratification and tweaking weather you may feel. As distant rain, even broken, the ice continues to influence, to teach, to cool a restless sea dot at the margins. Meltwater gushes in summer cataracts, plunging into Milans with a roar like surf in limestone caves. The water carves tunnels, then refreezes, cementing pipes that carry the next season's flow. Surface lakes drain in minutes, slicing fractures deep, a sudden drink for the thirsty bed. The ice size shifts, sometimes sprints, sometimes stalls, feed back. Again, you sip from a stream and taste mineral, cold, time. This water was sky last year, cloud 10 days ago, snowflake yesterday, and river tomorrow. You think of permafrost, ground that remembers cold so deeply it binds carbon in peat, roots, bones. As it thaws, microbes wake and feast, exhaling methane. And carbon dioxide, giggles of ancient swamps returning to air. Thermokarst pits collapse as ice lenses melt, changing drainage, tilting forests, toppling houses. The living ice extends underground, an unseen scaffolding holding whole ecosystems steady until warmth unthreads it. You imagine soil exhaling. In surprise, centuries of storage released like a long, slow sigh. Even sea ice, seasonal and thin, lives. It blooms with diatoms in briny channels, nurseries for copepods and fish. It thickens, ridges, rafts over itself like tectonic plates in miniature. It fractures with the tide, leads opening like blue veins, refreezing overnight into silver scars. Polar bears, seals, birds' communities choreograph movement to its pulse. When that pulse falters, the dance stumbles. You feel the fragility of timing, the tenderness required to keep rhythm. Heat and light speak through albedo. White sends sunshine back, dark absorbs. As ponds spread and soot settles, the surface darkens, taking in more warmth, inviting more melt. Feedback is a spiral. Staircase you can climb or descend. The living ice reacts, but the tempo is quickening beyond its practiced steps. You are here, watching the metronome speed up, feeling responsibility like both weight and invitation. Still, hope glints like sun on facets. Ice recovers when given cold and time. Glaciers regrow in shaded cirques. Snowfall can thicken thinning shelves if climate allows. People can choose to soften their warming breath, to slow the haste, to return seasons their rhythm. The ice will respond, always has. Its patience is long, not endless. Its memory deep, not invulnerable. Care is the difference between witness and partner. You lie on your back, letting your warmth melt a shallow cradle. Above, Cirrus strokes the sky. Below, a billion crystals knit and slip. You listen to your own breath, join the sheet's slow respiration. You count heartbeats against centuries and find comfort in the ratio. You are brief, but you can be kind. You are small, but you can tend something vast. Science becomes solace when it turns facts into understanding, and understanding into gentler choices. You picture classrooms where cores arrive like scrolls, museums where children touch meteorites, found on blue ice, councils reading graphs built from bubbles trapped in darkness. The living ice speaks through all these channels, asking not for pity, but for partnership, a respectful dialogue between warm blood and cold crystal. As twilight lengthens shadows and your journey arcs toward closure, you run your fingers over a wind-sculpted ridge. Tiny spicules break and drift, settling elsewhere, beginning again. The ice is never the same river twice, yet always itself. HO laddered into lattice, phase changing with mood and message. You whisper thank you, and the wind braids your words into a snow devil that dances briefly, then dissolves. The idea of an ending feels wrong here. Ice does not end. It transitions, it melts, it sublimates, it rains, it refreezes. Likewise, your story cannot close, only turn a page. Perhaps the next chapter is water or cloud, or stone. Perhaps it is policy, art, or song. Perhaps it is simply continued listening, the practice of tuning your pulse to slower beats. You rise, brush frost from your knees, and draw one last bright breath. The sheet beneath exhales minutely, an almost impossible motion you choose to feel. In that exhale is the planet's slow promise. Change is certain, care is optional, wonder is always available. You choose wonder, then care, then change, like stepping stones across a melt stream. Cold light spills over the plain as you turn toward camp, your footprints already softening. Behind, the living ice continues, its dreams folding, sliding, recording, releasing, while above, thin clouds streak signatures across blue glass. Ahead, a faint glow hints at human warmth, stories shared under fabric and starlight. Between the two, you walk, a messenger carrying silence made articulate. Somewhere deep below, the Earth's core hums, indifferent yet generous, sending heat upward that the ice translates into motion. Somewhere high above, photons born in the sun's heart scatter off snow, their journeys ending as brief glints in your eye. In between, your heart beats water, salts, Iona, tiny glacier, a tiny star, living and remembering in tandem. You pause at the threshold of light and dark, listen once more, and understand the ice's final lesson. To move slowly is not to be idle, to be silent is not to be empty. To be cold, you realize, can also be to cradle, to hold, to keep, to wait. You step into the dim glow ahead, carrying that patience like a small flame, and wonder what shape your care will take when the ice becomes water, and the story asks you to keep listening as it flows.